Hello and welcome to yet another episode of our podcast. As you can probably hear that we will be doing this this version in this episode in English, and it's it's a period of a mild version of a new lockdown, I guess. I mean, it's not a lockdown, but we're still geographically in the same, pretty much in the same place, in the same city, but social distancing and everything. So we're all in our different places, different rooms, and we're meeting on the video. How weird is that? But well, my name is Rustam. I have been to quite a few of those episodes, so I probably don't need much of introduction. I work mostly with architecture with cloud and Java at Computas. And let's introduce, should we introduce our guest first? I think we should do that. So our guest today is Dmitry. And Dmitry Chuyko, he is a performance guy at Belsoft, as he describes himself, and also OpenJDK committer. And well, hi, Dmitry.
Hello. Hi, Rustam. Hi, Mats. Hi, everyone.
So happy to have you here. Thank you for joining us today. And with me together is another usual suspect of this podcast is Mats.
Yeah, hi everyone. Good to be back in the podcast. I'm happy to talk about Java.
Exactly. So we will be talking about Java, we'll be talking about containers, and we will be talking about, all those things that are connected to it, things like security, a little bit of security, a little bit of, memory performance. I mean, since we have the quote unquote performance guy from Bellsoft, we probably need to talk a little bit about performance of those things as well. So where should we start, Dmitry? What do you think?
I think we can start the stating that it's so fine and safe for multiple years to use Java in containers, and probably everyone does it.
Hmm. And I mean, the first kind of horrible myth that comes into to my mind is the old one that we've been trying to kill and for quite some time, and I think it's been debunked by now. But probably we should mention that this thing of, oh, Java, it takes so much memory and it uses blah, and you cannot put that thing in the containers and this thing. So that thing is dead, right? Long time ago.
Right. It's like twice that.
Good.
So yeah, first stage was to detect actual memory limitations, not to be as hungry up to the operating system comes and kills the Java process, because it just doesn't see the boundaries of the actual container. And the second one is being more effective, really. So key thing here is uncommitting memory in garbage collectors, then that memory is not needed. So that lets many containers, for example, to coexist or to have lower memory limitations. So even you have some XMX specified or detected, you may still be using less memory than this amount of memory.
And when another thing, another kind of context thing, probably we should mention now when we're talking about these things. When we talk about Java, we're talking about what, at least 11 and upwards, or like 14, 16. What's the context here? Probably we should mention that as well, most of the time.
Yeah, 17 is better here, much better, I would say. So a lot of restructuring inside GCs and support for uncommit for more GCs. And for 11, you need latest updates or even some downstream distributions with additional backports to have this functionality more aggressive. To return memory to your actual systems.
Exactly. And when we talk about the distribution, there is a lot of them, right? So, I mean, you guys are making one. There is OpenJDK, obviously. There is one from the, what should I call it? The mothership. I mean,
There's no
Oracle.
OpenJDK. Excuse me, no such distribution called OpenJDK.
That's true. That's true.
Yeah.
That's actually also, that's another thing that's very confusing, isn't it?
Yeah. There is a container image called Soul, but it's still some distro. One of distros, and it also has its own some problems or issues.
Yeah, but maybe you can like introduce our listeners to a bit to like the difference between OpenJDK and say adopt OpenJDK and Liberica JDK as you're developing like the other implementations of OpenJDK. How is this concept? How these concepts fitting together?
So the project is called OpenJDK, and there are participants, companies, and individuals who contribute to that project. And there are distributions, always assembled by someone. It may be a kind of foundation or a project in Eclipse like Opheim, or it can be a company like Bellsoft, or that can be a container assembled by someone who maintains the port called official on Docker Hub. That surprisingly has the name OpenJDK. But that's just kind of naming. Like why a joke is why adopt OpenJDK is so popular, because it contains OpenJDK in its name, right?
That's I mean, it's been quite confusing with all this naming and everything. So it's a very good point to actually to talk about that and mention that and get that out of the way as well. But so Java and containers is one thing. So what you mentioned to this a tiny little bit about garbage collection, like new ways of doing that, and the improvements that leads to containers and all those things. But then you talk also quite a bit about small containers, so like tiny little ones. With as little as possible for many reasons, right? Memory,
Right.
footprint, security, and all the other things. So, what's up with that? Can you talk? Should we talk a little bit more about that?
Yeah, sure. In real world, we don't need, over 100 or 200 megabytes OS layer and a few dozens of security vulnerabilities just to run Java. We can avoid it easily. And we can go to the slimmest basement for running Java. That required some efforts in OpenJDK to support tiny muscle standard C library implementation. And now we have that great super small containers. The popularity raises. So some people still prefer like familiar environment. Okay, I only know how to install packages in Debian. All right, and then use some Debian-based container environment. But if not, just Linux and use Alpine, use Alpaca. It'll be fine.
I see. But then, yeah, go ahead, Mats.
Yeah, is this enabled by the module system, or is it like unrelated to
that? Sorry?
If that makes sense. Like we've spoken quite a bit in this podcast earlier about the Java module system. Like the modularization of the Java core.
Yeah, sure. You can even reduce the size of your container if you use JLink and if you strip off unneeded modules. Of course, that's another layer of optimization here. So you can optimize your operating system part. You can optimize your runtime part to take optimized runtime out of the box at first, then to strip it even more with trailing. And yeah, you can strip your application because it probably can be split if it's huge, right? Less dependencies as well. Or you can change your use more lightweight framework, for example.
And you can remove some packages or parts of it that you don't really need, and so it's quite interesting to see how much you can strip around those things.
Yeah, I know the exact answer. The smallest container image for kind of Hello World application built from particularly the Berica Lite and Opheim muscle. It's like 42 megabytes. So the magic number is 42.
Of course it is.
Yeah, so it's around 42 megabytes. That's the round minimum that you can get.
That's really cool. I mean, that's a very, very different kind of ball game from compared with full JDK, full everything, and all kind of things. That is probably in hundreds, right?
It's like 10 times smaller.
Yes, exactly. So it's kind of fun. That's really cool. And I remember, it's kind of sidetracking right now, but I just remember that when I was at university, we had this competition of trying to write the smallest possible hello world in Java, just like by cutting down everything that can be cut, just and so the idea was to make it the smallest possible, the compile, the class file. And that was actually quite fun. So it was now that times are gone, and now we are trying to squeeze out of the containers with Java as much as space as possible. That's fun. All right, but you mentioned containers. You mentioned different distributions, different ways of you have Alpine, you have all the other ones, and but we talked a little bit before we pressed the record button. We kind of talked a little bit about the security part of that, or well, at least security is quite a big part of it, but there are some other issues with that probably as well. Is using verified or unverified or kind of third party, or kind of thing that you called when we talked about that for random containers. Maybe we should mention that as well to our listeners, so they are kind of a bit aware of that.
Yeah, just be prepared that if you take something random, it might break unexpectedly, or there may be some important part missing. So if you see useful scripts in some containers, for example, the JDK, just take the scripts. Okay, don't choose JDK because of that.
So basically, so that's one thing, is that things can break, but the other thing is that you don't really know if it is a totally random descriptor file or container. You don't really have no idea what was there in. I mean, okay, fine, it actually says that it's going to run Java and everything, and it can probably run Java, but you have no idea what else have been added there or not added there, right?
Yeah, so we saw no kind of evil containers that really are mixed with some poisonous functionality that steals the data or something. Fortunately, no. But
worse than ever.
Yeah, I saw a few ones that were quite outdated or did not contain some essential functionality, JFR, for example, or profiling facilities.
So when we talk about that, we probably need to have, so people listening probably have, or watching for that case, they probably are sitting now and thinking, okay, fine, we should be careful, we should think about that, we should do that, but what's the kind of the recipe for a good, what should I do if I want to get started by moving my Java application into containers. So do you have some kind of very rough list of things that they can kind of check off and say, okay, well, I've done that, I've done that, I've done that?
Well,
Very high
testing,
level.
of course. Yeah,
Mhm.
you should have a testing system, and your containers must grow through all your environments, starting from development environment. You select and you know and measure your resource requirements, because you
Mhm.
have to think of limitations and so and put that limitations and take them in action.
Mhm.
To use as recent Java as you can, I would say, yeah, try that, and set up your update cycle. So your internal way of how do you update your runtimes and your base images. So what's the process? What's the channel? How do you get those images? Are there any troubles if you use Docker Hub? Are there any troubles with public free pull limits or whatever? So tune your processes. That's important.
So pipeline is a very, very important part of that, and from what I heard you saying, I think is also container registry of some kind might be a very good idea, because then you just build them, you put them there, and then you pull them
Yeah,
out,
sure.
put them in different environments, so you don't. It's
And
build once, kind of run everywhere kind of thing, right?
yes, and you can make tooling around that, like security scanning or tracking or whatever. Yes, that's a good idea.
I think I'll add to that. If you are using an app server like, say, Spring or Spring Boot or Quarkus or OpenLiberty or whatever you're using, there probably exists some Looker file or at least some information on the internet, like the usual way to do things with your app server. So that might be worth looking into as well.
Yeah, another good idea is to consume nice functionality already implemented for you by framework providers, or I don't know, cloud or stack providers. Like that, maybe if you use some cloud provider, it might be easier to start with container registry provided by the same cloud, or if you use a framework, it might be easier to build container images with the means of this framework. That's natural.
That's also a very, very good point. And actually, you remind me of one thing, Mats, when you mentioned that. We mentioned Spring, and we talked a little bit about Spring and containers there, and things like native images. Probably think that we probably should talk about in this podcast. So Spring native and all those things. What can we say about that? Spring in containers?
Yeah, Spring Native, it's still beta, I think, but it's very, very close to release. So, and for a long time, it's available as an experimental feature on Spring Initializer. So it's naturally one of easily selectable options for Spring. So, and if Paketo build packs in standard Spring container build, it's so easy to switch between native image container images and classical JVM container images.
Well, that's yeah, okay. That's really cool. So now we're talking about native containers, right? Maybe we need to talk a little bit more go into a little bit further into that. I mean, what is this thing? What we should probably give a kind of short uh, explanation, definition, whatever, of what do we mean by native containers, really?
Yeah, so using GraalVM native image technology, provided with any binary build of GraalVM, you can create the executable that contains both Java runtime and your code mixed together as a binary executable in machine codes right? It's just an ELF file, for example, for Linux. And you need only basic dependencies to run that. It even may be a binary runnable in Scratch container. Then standard C library is linked statically. It's also possible. Not, I would say, common, but still. And that's the main difference. You still have all the code that you wrote previously. In a good situation, there won't be any changes. If your frameworks and all the libraries that you have support that, you switch. It's not easy because you have longer build times, and you have binary that's, for example, not compatible with all the diagnostic tools that JDK has. But you can debug it, test it first in JVM mode, and then switch to native image mode and test it again, of course. And there are advantages of having this single binary. Sometimes it is size. I would say it is so for small applications. So if you have really a microservice, you'll have all that size close to that 42 megabytes, right? But for small Spring application, it would be like 60, maybe 70 megabytes. That's the size of binary. If you have larger application, and if you have additional optimizations, it may grow dramatically up to hundreds of megabytes. So it will be larger than JDK and jar. But you have instant startup time. You have instant performance from the start. That are key points of having that.
Exactly. I was thinking about to mention that. So, I mean, the one thing is size, but the other thing is actually the cold starts, especially with cloud native stuff, where you kind of expect to put your containers and they kind of are being hibernated in a way and woken up at some kind of random points of time, and you expect them to be there just and to be able to provide a proper response in no time. So this is kind of thing. One thing is that we have experienced, because Mats and I have a talk where we kind of play around with native, among other things, with native images and stuff, and we've experienced that one of the kind of, I don't know if I should call it downsides, but things that you need to kind of be aware of is the a resource used to build those. It might take a bit more resources to build it, but once you've built it, then they're quite fast and beautiful and slim and all those things.
Yeah, exactly.
Or maybe not slim. Yeah,
I almost don't build native images on my development machine. Even it is quite new, but still.
No, well, the
happy
reason,
with that.
yeah, the way we mentioned that. Well, you want to talk about that, Mats? So I don't do all the talking.
Yeah, sure. So what we were trying to do a build on Cloud Build, Google Cloud Build in our case. So yeah, with like a JVM. This was Quarkus though, but I guess it's kind of the same with all GraalVM based images. Like when we were building Quarkus JVM mode, there's no problem at all with like default settings. But when we're trying to build native mode, it used like 10 gigabytes of RAM or something. So we need like to maximize the resources available on Cloud Build. And on my local development machine as well, I need to close all the other programs in order to have enough memory to build into native modes. It's kind of heavy. I guess you can say that you trade like build time for runtime optimization in a way.
Right.
So yeah, well, which might make sense in many cases, maybe not others. So, but I guess you also can say that you lose. If I understood native correctly, it means that you run outside of the JVM.
You have JVM inside in that binary, so it does garbage collection, all the runtime things. But
yeah, so basically it gets fused into some kind of big binary with your code and JVM and all those things, and it just knows how to behave, and it just does, doesn't it?
Yeah, it has no bytecode. Like it's already compiled to native.
Actually, machine code.
but all other parts are there. And, I would say things they get better over the time, especially over the past year. Build time and memory requirements, they went down, but it's still a fundamental property of this approach, having all your code compiled ahead of time. Because if you look at same applications in runtime, then we put load on them. It takes minutes of working compilers in hotspot to compile the same, not all the code, but actual hot code. So we try it exactly at the same time, about the same time, yes. But we do it once and we don't do it again and again and on each instance.
Yeah, and that's probably one of the reasons, or well, not even probably, but that's one of the reasons why it's so fast to boot up and everything, because you don't have to load all those things and do all the interpretation of what, because you have like several layers of things with even with JVM, right? But here it's just everything is just finished kind of and ready for you to use in a way. But that's really cool. What else? Is there anything else that we should probably mention today when it comes to Java and containers? Anything that you?
Yeah, development environments.
Oh yes, that's actually a good point. Yeah. So what about that?
Yeah, here's an interesting point about native images, by the way, because they are native. So you won't be able to run a native image for one platform on entirely different one. Like if you compile for AR64, it won't run on Intel, and vice versa. And with Java, you just install proper JVM and you put the same bytecode and it runs. Not the case with native images, but we also have now extra popular development environment with different ISA. Max on Apple Silicon, and we develop there, and they have multiple options. Like if we use containers there, right, for our local development environment with containers, or we use native JDKs, basically we can use both x86 and emulation, right, and M1 native binaries for macOS AR64. You can also find such runtimes. And Docker, it now works there. There was a period then hardware was available, but no native Docker client. It's called like Docker Desktop. So,
are there any alternatives to that, or is it just Docker for now that runs that? Because Docker Desktop, that's, well, let's don't go into that hole of but it's the changing license agreements and all those things, and
you can run virtual machines. That's also an option. Like you can run Linux, and the more effective way would be run, of course, AR64 variant. And so there you can think of which kind of applications and containers do you prepare, because it's hard now to cross-compile native images, for instance. But for regular JDKs, you can do a cross-build for containers. So you can develop and test using one CPU architecture, but create containers for another one. That's possible.
That's pretty awesome.
That's really nice. I just had to check because I've been experimenting with moving things from Docker to Podman. So I just was looking into if that is supporting now Apple as well as M1 chips, and it seems it does. Seems like it does. So I haven't got the new Mac yet, so I kind of still have to wait with that to test it properly. But I just wanted to check. But yeah. Oh, that's cool. That is really nice. So development environments. Anything else that we need to mention about development environments, like some tools people should try out using, or that make developer life a bit easier for this kind of stuff?
Start the flight recorder. I don't get tired repeating that. That's
Well, I think this episode is getting a bit long, but I think we should kind of need to. I get this feeling that we should probably talk a little bit about Flight Recorder and explain what it is to some, because I think some people don't use it because they don't know about it, or kind of think it's a bit scary or something like that. Can we do a short elevator pitch for Flight Recorder?
Yeah, sure. That's a great technology in OpenJDK now, from 8 to up to most recent ones. Just take latest updates, and it is low overhead profiling built into your JVM.
Mhm.
And it produces some compact binary flight recordings that you can consume in special tools like a command line ones, or in a great tool called Java Mission Control
Mhm.
that's able to help you figuring out what really happened into your JVM for some period of time, or the very important period of time before it died. That's what really flight recordings are for, one of key points. And it's also now supported by native image. So you can get kind of limited, but still same format flight recording from your native image, and to work with that. Thanks to Red Hat team, I would say, yeah, that's a great contribution.
That's really cool. And I mean, I have to say, it is a incredibly useful thing, especially when things go bad, when things crash, and your application and whole thing just dies. It's really nice to actually being able to see, that's where we had the memory leak, or that's where we had the kind of bottleneck of some other kind. And those that is really, if you folks haven't tried that before, give it a spin and just see what you can get out of it, especially with the bigger applications. That would be quite fun to see things from a different perspective.
Yeah, I can think I did that just a couple of weeks ago. I used Flight Recorder because we had, well, a part of our application I'm working on, we're going a bit slow, and we were like reading the code and couldn't figure out why. So we tried like, okay, let's run this with Flight Recorder and see what happens. And we figured out, well, there is a bug, which means that we do this token generation like a million times when we really just need it once. Like, those kind of things are hard to see, but like if you just look at the code, but if you see, like, if you analyze it, then you see what's happening.
Oh, that's for sure. I mean, we've seen that many times. We've seen it with loading of things, like when you load things too many times, or not offloading things that you don't need. So basically, all shapes and sizes of things that can probably be classified as memory leaks, and you just don't think about it. Sometimes you just forget. I mean, we're good at reading code, but we're not really good at compiling it in our head and thinking as the compiler. So sometimes, bug may happen, I guess. I mean, that's the human nature. But yeah, I think we should, unless you guys have anything on, that you want to talk for a bit more, I think we should probably start rounding off. And then I usually like to finish those podcasts with a few, like, the main digest of what what we talked about, or even like starting points. Okay, let's say I want to move my Java into containers. I want to do this, or I want to do that. So what like 3 main points from this podcast, what people should try doing and stuff like that, or maybe 5. I don't know, as many points as you have. Just keep them single digit. Keep them single digit, number.
Try small containers. They've recent Java. They've great diagnostic tools, like we mentioned. Few.
Upgrade often.
Yeah. Plan your upgrade.
Mm.
Don't necessarily do it often, but please plan how to do that.
Yeah. Now I was thinking more just try to keep up with Java versions, really, because it will be harder and harder to upgrade if you wait for like people used to do in old days, wait for 5-10 years, I don't know, 6 years, and there's like, oh, now we're going to upgrade Java.
Yeah, and don't use random stuff. Please take your requirements, work out your requirements, and use them.
All right, I think that's a very good summary of the things that people should think about when creating containers or moving their stuff over to containers and their Java stuff to containers. All right, I think now it's time to round off this episode. And yet again, big thanks to Dmitry, to Mats for being with us today and chatting. And it was really, really fun to do that, and really hope next time we get to actually sit in the same room and actually do this recording in the way we used to, not just hiding in different rooms and different geographical locations and just doing the video meetings over and record those.
Let it be so. Thanks for having me.
Yes, indeed.
Thanks for
everyone.
coming. All right, then. Bye everyone. Thanks for listening. See you soon.
See you.